negative r. By substitution, to find the value of r equals 11,760 Newton. Therefore, with kilogram, r is 1,200 kilogram weight or kilogram per ton, r equal 50. The distance traveled by separated car within a minute after separated, then S equal V naught T plus half AT square. By substitution to find the distance, S equals 882 meters after separated. Second, when study the motion of the train before separation, the train was moving with uniform velocity before departation. M equals 220 ton. Therefore, the moving force equals the total resistance. Resistance ton 50 kilogram weight. Therefore, the force equals MA. 50 times 220, 11,000 kilogram weight. Third, when study the motion of remaining part of the train after the last car has been separated, M equals 160 ton, F equals 11,000 kilogram weight, resistance ton per ton equals 50 kilogram weight. Equation of the motion equals is MA equal F minus R. By substitution to find the value of A, therefore A equals 3 over 50 meter per second square. From the laws of motion, S equal V naught T plus half AT square. To find the value of S by substitution, therefore S is 1,872 meters. Distance between the remaining part of the train and separated car at moment of its resist, we subtract 1,872 minus 882. Answer is 990 meter. My dear student, by the end of the application about second law, now we are taking problems about the third Newton law. What is the third Newton law? Third Newton law, every action has reaction equal in magnitude and opposite direction. My dear student, look at the first example. My dear student, look at the first example. Body of mass 4 kilogram is placed on the floor of the lift. My dear student, a body of mass 4 kilogram is placed on the floor of a lift. Find the pressure of the body exerted on the floor of the lift when the lift is moving vertically upwards with uniformly acceleration 98 centimeter per second square. Look at the solution. My dear student, look at body inside left. Body has weight mg, pressure equals speed, motion upward. The motion is upward. What is the equation, my dear student? Excellent. B minus mg equals ma. A is acceleration, B is pressure of or reaction of the plane on the body or the lift on the body. My dear student, therefore we find the value of B equals MA plus MG. We take M highest common factor, then B or reaction force equals M times bracket contains A plus G. A is acceleration, G is gravity force. Equals 4 times bracket by using convert centimeter to meter is acceleration 98 centimeter became 0.98 meter squared, meter second squared, plus 9.8, therefore B equals 43.12 Newton. Therefore, my dear student, B equals 4 multiply A plus G. A acceleration 0.98, G 9.8. Answer is 43.12 Newton. We can divide it by 9.8 to convert Newton to kilogram watt. Answer is 4.4 kilogram watt. My dear student, Newton, which is bigger, Newton or kilogram watt? Kilogram watt. Kilogram watt, 1 kilogram watt equals 9.8 Newton. If we convert from Newton to kilogram watt divided by 9.8, 43.12 Newton divided by 9.8 equals 4.4 kilogram watt. My dear student, look at another example. Find the reaction of a lift on a person inside it, whose mass is 60 kilogram. Its units on Newton in the following cases. Number 1, lift is at rest. Number 2, lift moves vertically upwards with uniform acceleration of magnitude 1.7 meter per second square. Number 3, find the lift moves vertically downward with uniform acceleration of magnitude 2.8 meter per second square. The third case. Solution. Look at, my dear student. In the first case, R equals mg. R equals 60 times 9.8 equals 588 Newton. Rest. Since in second case R minus mg equals ma, by using highest common factor we can form R equals m multiplies g plus a. Substitution about m and a, g. R equals 60 times bracket contains 9.8 plus 1.7 equals 690 Newton. In third case, my dear student, the motion is downward. mg minus r equals ma. Therefore, mg minus ma equals r. Or r equals m common factor multiply bracket contains g minus a. In case the motion is vertically but in downward, r equals m multiply g minus a. In this case, by substitution, r equals 60 times 9.8 minus 2.8, answer is 420 Newton. Dear student, look at another example. Lift moves vertically with uniform acceleration of 7 centimeter per second square. If scale is hanged at its ceiling carrying a body of mass 14 kilogram. My dear student, lift moves vertically with uniform acceleration. A is 70 centimeter per second square. If scale is hanged at its ceiling carrying a body of mass 14 kilogram. Find the scale reading in kilogram watt if number 1, lift is moving upward. Number 2, lift is moving downwards. Look at the solution. In this case, my dear student, the lift is moves upward. Therefore, with acceleration equals 7 centimeter per second square, therefore A is 0.7 meter per second square. A equals 70 centimeter per second square. Means equals 0.7 meter per second square. My dear student, A equals 0.7 meter per second square. R equals M multiply bracket contains G plus A. G gravity force, A is acceleration. By substitution, about M equals 14, G equals 9 point E, gravity force, acceleration 0.7. Therefore, what is R? Equals 147 Newton. By using divided 9.8, therefore, we find the value of R equal 15 kilogram with approximation. My dear student, when convert Newton to kilogram weight divided by 9.8. Therefore, R equals 15 kilogram weight. In second case, my dear student, the motion is downward. What do you mean? mg minus r equals ma. mg minus r equals ma. Therefore, mg minus ma equals r. By using m highest common factor, therefore r equals m multiply g minus a. By substitution about m, g, a, therefore we can find the value is r is 127.4 Newton equals 13 kilogram weight by using divided by 9.8 when convert to Newton to kilogram weight, R equals 13 kilogram weight. My dear student, by the end of the lesson, we know that Newton's law very important to improve this rule to calculate unknown of F or acceleration. The moment, my dear student, or Newton's law is very important in our life. Don't forget, math symbol, think, work, produce. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.